The decibel is a measurement used when comparing two sound intensities. The simplest method of comparison would be to compute the ratio of the intensities. For instance, suppose we have a sound intensity I equal to 8 times 10 to the negative 12 watts per meter squared, and choose the reference to which we are comparing to be I0 equal to 1 times 10 to the minus 12 watts per meter squared. We can then compute I divided by I0, which is equal to 8, and state that I is 8 times as great as I0. However, because of the way in which the human hearing mechanism responds to intensity, it is more appropriate to use a logarithmic scale for the comparison. For instance, the intensity level beta, expressed in decibels, or dB, is defined as follows. Beta equals 10 dB times the log of I divided by I0, where log denotes the common logarithm to base 10. I0 is the intensity of the reference level to which I is being compared, and is sometimes the threshold of hearing, given by 1 times 10 to the negative 12 watts per meter squared. With the aid of a calculator, the intensity level can be evaluated for the values of I and I0 given in our example, as beta equals 10 dB times the log of 8 times 10 to the negative 12 watts per meter squared divided by 1 times 10 to the negative 12 watts per meter squared. This equals 10 dB times the log of 8, which is equal to 10 dB times 0.9, which equals 9 dB. This result indicates that I is 9 decibels greater than I0. Although beta is called the intensity level, it is not an intensity, and does not have intensity units of watts per meter squared. In fact, the decibel, like the radian, is dimensionless. In order to understand the meaning of an intensity level of 0 decibels, we set the intensity I equal to I0 to get beta equals 10 dB times the log of I0 divided by I0, which equals 10 dB times the log of 1. Since the log of 1 is 0, we get beta is equal to 0 decibels. Thus, an intensity of 0 decibels does not mean that the sound intensity I is 0. It means that the intensity I is equal to the reference intensity, I0. In order to give some intuitive feel for the intensity levels of things that many of us can compare, the table shows some typical sound intensities and intensity levels relative to the threshold of hearing, I0 equals 1 times 10 to the negative 12 watts per meter squared. First, note the threshold of hearing on the table has an intensity level of 0 decibels, as it should. Normal conversation, perhaps about the intensity level of the audio on this video, is about 65 decibels. A live rock concert is about 120 decibels. Above that, we approach the threshold of pain and enter a region where hearing damage will likely occur. Now suppose we want to compare the intensity levels of two different sources, perhaps audio systems, with intensity levels beta 1 and beta 2. The difference, beta 2 minus beta 1, is given by 10 dB times the log of I2 divided by I0 minus 10 dB times the log of I1 divided by I0. This is equal to 10 dB times the log of I2 divided by I0 minus the log of I1 minus I0. A difference in logs results in the log of the ratio, so this equals 10 dB times the log of I2 divided by I0 divided by I1 divided by I0. I0 cancels, and we are left with beta 2 minus beta 1 equals 10 dB times the log of I2 divided by I1. Note that the reference intensity, I0, is no longer a factor. In summary, the decibel, dB, is a measurement unit used when comparing two sound intensities. The intensity level, beta, expressed in decibels, is defined as beta equals 10 dB times log I divided by I0. The threshold of hearing is defined as I0 equals 1 times 10 to the negative 12 watts per meter squared. Finally, the difference between two intensity levels B1 and B2 is beta 2 minus beta 1 equals 10 dB times the log of I2 divided by I1.